going to take a look at the arithmetic operations, adding, subtracting, multiplying, and dividing as it relates to functions. And then we want to take a look at the special operation called function composition, which is unique to functions. I'll show you two approaches to the addition of these functions with substitution. The first one is we're going to take the 0 and substitute it into the elf function. So here's the elf function. Substituting a 0 into the elf function gives 3 times 0 minus 4, which is 0 minus 4, or negative 4. Then we'll substitute 0 into the g function. Here's the g function. Substituting a 0, we get 2 times 0 squared minus 1, which is 0 minus 1, or negative 1. So now that we've done each of those individually, we're going to add those together. So negative 4 plus negative 1 would be negative 5. Now the other approach involves first combining the two functions. So this time we're going to take the elf function, 3x minus 4, the g function, 2x squared minus 1, and then subtract those. So all we're doing is what I've got the circle around, f minus g. We're going to create a new function out of this. And so the parentheses on the first one, I put those because it was the elf function. Don't need to be there, so we'll just erase them. However, the second parentheses, because there's a minus on the front of it, means we need to use the distributive property. We can combine the negative 4 and the 1 together. And then we can substitute the 4. Twelve, 16 times 2, 12 minus 32, and negative 20 minus 3, From the previous two examples, I think you'll probably agree that the easiest to do, if you're going to be substituting anyway, is to go ahead and do the substitution at the beginning. So here we'll substitute the negative 2 into the elf function. I'm going to come over here and substitute the negative 2 into the g function. When we get each of those, we will multiply. So on the first one, 3 times negative 2 is negative 6, minus 4 is negative 10. In the second one, negative 2 squared is positive 4, times 2 is 8, minus 1 is 7, and negative 10 times 7 is negative 70. Likewise, in the second one, we're going to start with the elf function, 3x minus 4. That's 3 times 3 minus 4. And then below that, the g function, 2 times 3 squared minus 1. So in the top, we're going to have 3 times 3 is 9, minus 4 is 5. In the bottom, we're going to have 3 squared, 9, times 2 is 18 minus 1 is 17. Now again, you can handle fractions on your TI calculator. This one does not simplify, therefore that's our final answer. Now this one is sort of a repeat of what we did. You notice here we've got a F plus G. Now perhaps you notice the difference in this one and the ones that we were just doing. There's no number. So basically all this is saying is just add the two functions. And so here is the F. Here's the G. And we want to add those together. Notice the X doesn't do anything. And so, like the previous one, the parentheses on the first one are not necessary, so we'll write this down without parentheses. On the second one, the parentheses are likewise not necessary because it's a plus, not a minus. So that is still just a 4x plus 5. We can combine the x's together. And there's our answer. Now the domain of this, basically, if you look at this, it's a polynomial, and the domain of all polynomials is all real numbers. Similarly, we're going to be subtracting these, ignore the x, and the f comes first. So x squared minus 3x, 4x plus 5. The first parentheses aren't needed. The second ones have to be handled appropriately. And then we can combine things together. And similarly, the domain is all real numbers. So likewise, on this one, we're just multiplying the two functions. So we're going to write down the F, then the G, and use our process. We're going to multiply first times first. Outside, inside, and last. Does that sound familiar? There's an acronym in there. So x squared times 4x would be a 4x cubed. X squared times 5 would be a 5x squared. Negative 3x times 4x would be a negative 12x squared. And then negative 3x times 5 would be a negative 15x. The two middle terms can be put together. And the domain of all polynomials is negative infinity to infinity. Now the vast majority of the time, this one is pretty straightforward. Again, there's no computations that involve the x, but if we take the f function, x squared minus 3x, and the g function, 4x plus 5, unless this simplifies, then we're through. And as I just said, 90% of the time, we're through. However, we do want to sort of verify that it doesn't simplify. So in the top, if I were to factor the x squared minus 3x, that would be x times x minus 3. 4x plus 5 does not factor. So unless we have something that's identical, which this is not, then we're through. So again, this one was through in the very first step, just by putting the f on top and the g on bottom. So notice on this one, the small circle between the f and the g. Now that is not multiplication. That is a special operation called composition. Now we read this as f of g. F is a function of g. And so whether you read it or not, as long as you can do the operation, you're in good shape. So very much like the first ones I showed you, let me show you how to first, when you have a number out here, do the substitutions and then combine them together. Now please watch the order in which this is done. We're going to start with the g function, the one closest to the 2. So we just kind of think of this as, okay, I want to do g of 2. So here's the g function, which is 2 over x, and we're using a 2 in place of the x, which comes out to be a 1. Now we're going to take that answer and put it into the f function. So the f function is the square root of x, which we're going to use the answer we just came up with. Now that comes out the square root of 5, which does not simplify, so that is our answer. And I'll show you the other option as before. When I look at this g of f, if I write down the g function, since it comes first, that's 2 over x. Now I'm just going to put parentheses where the x is. Then, in those parentheses, I'm going to put the second function. The f function is the square root of x plus 4. So this is the composition function. Now we'll substitute a 5. So substituting a 5, we get 2 and the square root of 5 plus 4. 5 plus 4 is 9, and the square root of 9 is 3. So just like with the arithmetic operations, we still need to be able to do this generically. Now again, please make sure you recognize the x that's out here is only symbolic. You don't do anything with the x. You want to combine the two functions together this way. So again, the technique is start by writing down the f function. Where there's an x, put parentheses. So the f function is the square root of x minus 1. Then, in the parentheses, put the g function. Now the g function is 2x plus 5. Now technically, that's our answer. Oftentimes, we're going to be required to do some simplifying. So let's see, what would we do to simplify this? The 2x plus 5 inside the parentheses is, that is unnecessary. So we'll just erase them. We'll combine the 5 and the 1 together. 2x plus 4. We cannot combine anything else. We cannot extract anything from the square root. as in we can't simplify anymore. So that is the answer. Now, I think we've talked about this before, but I'll go ahead and go through it here just in case. When we're finding the domain of a square root, we take the stuff that's under the square root and recognize that that has to be positive or 0. And then we can solve that inequality. And so here is -2. We're shading to the right of that. And it has a solid dot on it. In interval notation, that would be -2, infinity. And in the final example, we're just changing the order in which we're doing the composition. So again, whatever letter comes first, you start by writing that down. 2x plus 5. And then in the parentheses, you put the second function. Now, other than taking the parentheses off, there's no other simplifying to be done. So in determining its domain, the key is again the square root. The thing that's in the square root has to be positive or 0. Adding 1 to both sides. Here's the 1, and we're shading to the right. And it's equals, so we got a solid dot. That would be 1, infinity.